Hi everyone. In the previous video, we understood that using CSP via meta tag is not the best way. The best practice to use content security policy is via the response header. I have the same index HTML page, but this time I am serving it via Node.js server. If we reload our UI, it works as expected. Now to add content security policy to this UI, we can simply add the header with content security policy, and to start with, we can use script resource as none. Now if we reload the UI, we see that the loading of the scripted block. And the reason is, if we look at the response header, we see that the script SRC is null. In case of meta tag, first the HTML was received where we had the meta tag, so browser continued to parse it, and then it laid the policy, and then only it was allowing the downloading of resource. But whenever browser receives the response header, that is the first thing that the browser does. So in this case, the content security policy is the first thing that is laid. Then the HTML response is received, which browser starts parsing. So when compared to meta tag, this is much safer because there will be no way an attacker can inject a script even before the HTML is received, because content security policy is the first thing that is laid here, even before the response is received. Now, how do we allow this two requests to download resource as expected? So for that, we can change the none value and use the required values. Now, if we reload the UI, it works as expected. So currently we have allow listed cdn.js.fed.com, and because of which this jQuery min.js is loading as expected. But how do we differentiate whether this jQuery min.js is getting loaded as a part of a normal flow or it is getting injected by some attacker? To differentiate that, we have a token-based mechanism and we call it nonce. To add nonce as a part of security policy, we can simply change the value to nonce-$nonce. Now, in this case, this nonce is a variable that we compute, which is supposed to give us a unique UUID. So every time we make a request to this server, a unique ID will be generated, which will be attached as a part of this content security policy. Now, if we reload the UI, we see that this two script loading are blocked. If we look at the content security policy, it has generated a new UUID. Now, since every time we hit the server a new nonce is generated, we will see that if we reload the UI, the ID is different. Now, if this ID, if we are able to pass it in this two script, we know that definitely these two scripts are getting called as a part of this response that has been received, because the ID is unique per request, and this ID is generated as a part of this localhost request. To do that, we can change modify our HTML, and for every script tag, we will use this attribute. Now, if we reload our UI, we see all the scripts are loading as expected. Now, how is this happening? So if you look at this, so the content security policy is having some ID. And if you look at the response for this, it is holding the same ID. Every script tag is holding the same ID. Now, since the ID that was received from the content security policy as a part of the header, which was the first thing that browser received, is matching when it is trying to download a particular resource, it will always consider that it is coming from a trusted source and it will allow the download. Now, what if there is no nonce? Now, if there is no nonce, for example, if some attacker is trying to inject only jQuery.min.js, we reload the UI, we see it is blocked by CSP, because whenever this localhost receive, it has seen that there is no nonce, so it blocks it. So it understands that it is not coming from the source where it is intended to come from. Now, how is this response getting the actual nonce value? So if we look at our server-side code, what happening is, once we have generated the nonce and we are setting it the header, at the same place we are taking this HTML, that is this index HTML, and we are replacing all occurrences of CSP nonce with the actual value. So every time whenever a new header is received, that a new nonce is received, we know that the index HTML will always have that same nonce. So that way we know these two will always match, and hence the browser can consider that that is a trusted flow. Now, it is impossible for an attacker to add the nonce. Why? Because in our previous video, we already saw whenever an attacker will be trying to inject a script, mostly it will be via some API. Now, this nonce will be different for every user and whenever they loads the page. So it is highly impossible for an attacker to add a nonce as a part of script injection, which will match to some user. Now, I'll remove this, and so in our script.js, we have JS that is loading from self domain. But what if this script.js is internally loading one more script? We reload the UI, we see it is blocked. And the reason is this doesn't have a nonce. And neither this CDA.js is now allowed listed as a part of this content security policy, as we see over here. So this can happen with any library that we are using, any JavaScript that we are loading. What if jQuery min.js is internally loading any other JavaScript? We can't apply nonce there because nonce is getting applied only if we are loading script from our server, and that's the place where we can actually update the nonce value for the index HTML. But if it is getting loaded from some other server, like in this case jQuery.min.js, it will never hit this block, and hence because it is in the other server, and hence it is very difficult, it is impossible to update the nonce. In that case, we can use something called a strict dynamic. To add strict dynamic, we can simply use the key strict dynamic, and if we load our UI, we now see it is loaded as expected. So what strict dynamic does is, if any of a script is marked as trusted, whatever internally that script call will also be marked directly as trusted. In this case, since script.js is marked as trusted because it has the correct roles, internally whatever script is calling via this non-parsed way, it will be also marked as trusted. So to recap, nonce stands for number used only once, and it is used to allow a specific element. In our case, we allow listed script elements. In case of nonce, whenever someone is requesting for a resource, the index HTML, the server-side index HTML, which will have a particular variable that will be replaced via the random generated value. And once it is generated, we will also update the header to contain the same value. Now, when it reaches the client, or this script nonce, that value will always match with the content security policy header, and hence it will be allowed to download. Thank you.